Okay, so we're going to peek inside something you don't normally get to see, the operations manual for a colossal marine diesel engine. Now, these things are usually incredibly dense, right? Super technical. But hidden inside all the procedures and the warnings, there's a really cool human story about skill, about danger, and about the ritual of bringing a mechanical giant roaring to life.
I mean, think about starting your car. You turn a key, you push a button, and you're off. Simple. But what happens when the engine itself is a multi-story piece of machinery? Yeah, it's not just a simple act anymore. It's a carefully orchestrated ceremony. And that's really the question we're diving into here.
Before anything can happen, you gotta understand the environment. This is not your garage. This is the engine room of a massive ship. You're surrounded by these immense pieces of metal, pipes carrying fluids at insane pressures, and there's this potential for extreme heat and noise everywhere. You can just feel the power of the machine, even when it's completely silent.
The very first thing an engineer has to learn is the machine's own language. And they aren't just symbols, they're stories of what could go horribly wrong. That little flame icon isn't a suggestion, it's a promise of a nasty burn. The moving gears? That's a force that can pull you right in. Every single warning is a potential disaster. And understanding this visual language, that's your first line of defense.
So, with the dangers understood, the preparations begin. And this is not just kicking the tires, you know? This is like a pre-flight checklist for a machine that can't exactly pull over to the side of the road if something goes wrong. Every single step we're about to see is part of a deliberate ritual, and it's all designed to stop a catastrophic failure from happening miles out at sea.
All right, the ritual begins. First, the cooling water gets preheated. You see, starting this giant from cold could cause thermal shock and literally crack the metal. Next, the pumps kick on, circulating lube oil and water. It's like getting the blood flowing before a big workout. Now, step 3 is absolutely critical. The engine is turned over, slowly, for one full revolution. This is to make dead sure there's no liquid trapped in the cylinders, which could cause a total disaster. Finally, with the fuel pumps running, all the pressures and temperatures get one last check.
And the timing of that turn? Yeah, it's non-negotiable. It has to be done within the last 30 minutes. This is the final check for something called a hydraulic lock. See, if a cylinder is full of liquid, fuel, oil, whatever, and the piston tries to compress it, well, you can't compress a liquid. That incredible force has to go somewhere, and it can be violent enough to bend or completely break components that weigh multiple tons. So this final, slow turn is the very last chance to catch a disaster before it happens.
Okay, now we need to talk about the invisible enemy in every engine room, oil mist. Just think of it like a fog of vaporized oil. It happens when a part of the engine gets way too hot, a hot spot, and starts to cook the lubricating oil. This mist is incredibly dangerous because if you mix it with air, it basically becomes a powerful explosive fuel inside the engine itself.
So, the checks are done, the fluids are circulating, the dangers are understood. Now, with permission from the bridge, comes the moment of ignition. All of that meticulous preparation, all that procedural ritual, it all leads to this one single powerful moment.
This quote right from the manual, it just explains perfectly why that invisible oil mist is so terrifying. If there's an overheating problem and an alarm starts screaming, the absolute last thing you do is rush to open up the crankcase. That rush of fresh air could be the final ingredient for a devastating explosion. The procedure is clear. You have to wait.
The moment arrives. The main starting valve is opened. A massive blast of compressed air, we're not talking spark plugs here, slams the pistons down. The crankshaft begins to turn. Fuel is injected, and with a deep, shuddering roar, the engine ignites. The ship's heart begins to beat.
But the work is far from over. The second it's running, a flurry of checks begins. Is it spinning the right way? Are all the exhaust valves opening and closing like they should? Are the turbochargers spooling up? This isn't a celebration, it's confirmation. Did the giant wake up healthy, or is there an immediate problem we need to deal with?
Once the engine is stable, the job switches from starting it to monitoring it. And this is like a constant conversation between the engineer and the machine, a process of reading its vital signs to make sure it stays healthy for the long voyage ahead.
And that conversation is complex. I mean, it's not just looking at a simple gauge. Engineers use tools like this, a nomogram. It's a kind of advanced chart to cross-reference a ton of data points, like temperatures, fuel quality, pressures. It's a whole science of turning a sea of numbers into a true picture of the engine's performance, into intelligence you can actually use.
So what are they looking for? Well, think of these just like a person's vital signs. Scavenge air pressure, That's basically checking how well it's breathing. Exhaust gas temperature tells you about the health of the combustion in each cylinder. And lube oil pressure, that's the engine's blood pressure. A sudden drop there is a huge warning sign.
But here's what's really fascinating. Experienced engineers, they go way beyond the numbers on a screen. They see patterns. They learn the unique quirks and the personality of their specific engine. A tiny, almost unnoticeable change in vibration or a subtle shift in sound that a sensor might miss, a seasoned engineer can feel that. They know that trouble might be days or even weeks away.
Which brings us to the ultimate test. What happens when, despite all the checks and all the monitoring, something goes wrong? This is where procedure meets pressure, and it's where the human element is the most critical thing of all.
So under normal conditions, the engine's on remote control. It's all managed by automated systems. But in an emergency, they switch to emergency control. And just look at the difference here. The governor, the thing that automatically controls engine speed, is shut off. The engineer is now controlling the speed by hand, standing right next to this thundering machine, feeling its every response. All the automated safety systems are off. It's a moment of complete fusion between human and machine.
And the list of potential problems is just immense. We're talking about a fire inside the engine's airbox, a turbocharger failing, or a multi-ton piston cracking under the strain. Each one requires a unique response, and it has to be diagnosed and executed under incredible pressure, with the safety of the entire ship and crew on the line.
And this really gets to the heart of it all. This entire operations manual, as detailed as it is, it's just a map. It shows you the terrain, it shows you the known routes. But in a storm, in a real crisis, it's the engineer's experience, their intuition, their feel for the machine that acts as the compass, guiding them to the right decision.
It really leaves us with a critical question, doesn't it? We've walked through this incredible ritual of human and machine interaction, from the first safety warnings all the way to manual emergency control. In a world that's moving faster and faster towards full automation, what is the true value of that seasoned human intuition when the alarms are screaming and all the systems fail?